Hi again. In this lesson, we're going to switch over to means, which is really exciting. So we're going to do simulated and theoretical confidence intervals for a mean. All right, so let's say we're interested in how many credits Stat 244 students take at PCC. So I have a random sample. It is a fake random sample of 15 students. Now we'll get to do a sample of our class as well, whether you're online or in person. We will do that. So, but this is just made up random sample for just for right now. Let's explore with this data in StatKey, and then we're going to create a confidence interval using bootstrapping. Okay, before we get over to StatKey, let's do a little notation refresher for means, okay? And remember, numerical, a mean is for a numerical variable because it's numerical, it has units. We can take the average of it, right? Versus categorical, which is yes, no, or some number of categories. Numerical variables almost always have units, okay? So now we're going to got to remember to write the units after each statistic. Okay, our population mean is mu, and we pronounce that mu, mu. Our sample mean is x bar, which we read x bar. Our population standard deviation, we use the Greek letter sigma for that. And if it's for a sample, our standard deviation, we use the letter s, okay? S is S. Okay, so just remember now we've got two things, a mean and a standard deviation for each distribution we'll be looking at. Okay, question here. What is the best point estimate for the number of credits Stat 244 students are taking? Okay, so we have this sample here, and kind of makes sense we would want to take the average of that, right? So we would use x bar because we're talking about a sample, and we're going to calculate this. Let's go over to StatKey because that'll do it for us. And also I have the data, since we'll have lists of numerical data now versus just a numerator and denominator for a proportion. So you're likely going to have some kind of spreadsheet that has the data in it. Okay, so here's our data set for credit hours taken. So I'm actually going to copy this. So you should see a link in D2L to this data spreadsheet. You could also get it from the Word document as well of the notes. And now I'm going to go over to StatKey, and we're going to go back to the home page of StatKey. Remember, Bootstrap confidence intervals are in the middle, and we're going to do the top one, confidence interval for single mean. You could also do a median or standard deviation, but we'll just be doing the mean. Okay, and some data sets will be built in here, but this is not one of those. So I'm going to click on Edit Data, and then I'm going to delete all this. And I actually didn't copy my heading because it was kind of big, so I'm going to say credit hours, and then I'm going to paste Control V or paste right in there. Now, the only important thing, we only have one column, so don't worry about that. Data has a header row. If you have a header row, you want to make sure that's checked. If you don't, if you just put the numbers, you want to make sure that's unchecked. Okay, it'll get confused if it doesn't match. It'll think the first number is the header if you have this checked. Okay, so let's hit OK, and then we see our values right over here, and it calculates the average for us, 14.2 credits. Okay. Now we could also, another kind of cool thing to do is in our spreadsheet, we could do equals average. It is thinking it knows what I want to do, and it's correct that I want to average this column, and it's also 14.2. Okay, I'm going to delete that so that is not there for anyone else to see after this, but you can use the spreadsheet for that too if you want. Okay, so we've got an average of 14.2 credit hours. Let's put that down in our notes. 14.2 credits, right? Credits or credit hours, either one. Okay, so that's a point estimate. Remember, a single point, but we want to have a range because people will tend to believe that that's the exact value, right? But we want to give an average, and we need to have a confidence level associated with that. So let's do write and interpret the 90% bootstrap confidence interval, or maybe it should be a 90% bootstrap confidence interval, since if you do that repeatedly, you'll get slightly different things. For the true population mean of credit hours that students, PCC Stat 244 students take. Okay, so let's go over to Stat Key for that. Okay, so we've got our original sample, and remember what the computer is doing for this one. So it's sampling with replacement. So we've got 15 data points in here. So imagine 15 slips of paper, and each sample is going to be 15 again, but we're going to pull one out, put it back in, mix them up, pull one out, put it back in, mix it up, pull one out. So that way we're going to have we will have repeated values. So for example, say this person who's taking 21 credits, that might come up multiple times, or 8 credits, that might come up multiple times. And that just gives us a good idea of sample to sample variation, the standard error. Okay, it's amazing it works that way, but it does. So let's go ahead and do it's been a while since we've done bootstrapping, so let's just do it again. Here's one sample. You can see the 15 came up a little more than in the original. We got the 21, but we don't have the 8. Okay, so here we get an average of 14.6 credits. Do another one. That one came out to 14. So we do have the 8 and 21. It's a little different in the middle. Just do a few of these until you remember what's going on with bootstrapping. So it's been a little bit. Yeah, so you can see they're changing just based on which ones are randomly selected with replacement. Here we didn't get the 20, and so we got, still came out to 14.2 though, so fascinating. Okay, I'm going to do 2,000 now. It's okay that I have a little over 2,000. And then we always do two-tail because a confidence interval has two sides, and we put our confidence level in the middle top number. So 0.90. Okay, so we would expect 90% confidence, the true average credit hours Stat 244 students are taking is between 12.7 and 15.5. Okay, so I'm going to write this down and then I'll go back to the notes. Okay, so I wrote down the 12.7 to 15.5, and I'm going to write credits after that. You could put it after each number, but I'm just going to write it one time. Okay, so let's write the interpretation I just mentioned there. With 90% confidence, we can say the true mean. Remember, you could also say population mean. True mean credit hours taken by Stat 244 students is between 12.7 and 15.5 credits. Okay, and then I have a screenshot here just for your reference. Let's see how this one came out. keep that interpretation up there just for another moment. Okay, so just to refresh our memories, here we have our X bar. So they give us our sample mean. Very nice. We could always double check it. And then we put our confidence level. We do two-tail confidence level. In the middle top box. And the values at the bottom are the confidence interval. So that's saying the middle 90% of these simulations were between, now this is interesting, it's very close, 12.8 and 15.7. Okay, so these will vary a little bit. So between here and here is your confidence interval, and I want to remember these are credits. Okay, so whatever your units are will be down along the bottom, and this is your frequency along the vertical axis. Okay, great. So you'll be practicing putting in data sets into StatKey, doing simulations, and I'll see you in the next video.